Today's problem is last moment before all ants fall out. Difficulty medium. Has a high accuracy rate though. Let's see, we have a wooden plank of length n units. Some ants are walking on the plank. Each ant moves with a speed of 1 unit per second. Some are moving left, some are moving right. When two ants moving in different directions meet at some point, they change their directions and continue moving again. By change their directions, it means they turn around and start going in the opposite direction. Assume changing directions doesn't take any additional time. When an ant reaches one end of the plank at time t, it falls out of the plank immediately. Given an integer n and two arrays left and right, am I able to move this over? Maybe we can see all the code. And yeah, here we go. All right, so here's the input n and two integer arrays left and right. The positions of the ants moving to the left and right return the time when the last ant falls out of the plank. Okay. I'm not really familiar with this question. I haven't heard it, and I don't think I would want to have somebody just speak this to me in an interview. Getting it with the picture is helpful. Okay, let me see here. Left. And we have two, okay, and then we have one at 0, and there's 1, 2, 3, 4. Okay, so here's what we have in this example. We have one ant going left, and that ant is at position 2, right? Now, if there weren't any other ants in the way, that ant would fall off any ant moving left, whatever their position is, that is how long it's going to take them to fall off the plank. So in this case, this ant would fall off at time 2. Now, ants moving to the right are going to fall off the plank at time n minus whatever their initial position is. So that would be, since n is 4, these ants would fall off at 4, 3, and 1, respectively, without any other ants in the way. Okay? So let's make this observation, though. And that is, let's see, which one is going to be easier to do? Well, you know what? We have to use, we have to use this one. So that one's going to hit there. That one is going to hit there. Yeah, that's fine. Okay. Let's make this observation. If this ant at 2, in 2 seconds, without any other ants in the way, that ant is going to be at position 0, moving left. Now, this ant, in 2 seconds, without any other ants in the way, this ant would be at position 3 and moving to the right. Well, what happens after 2 seconds is, and then we have these ants running into each other as well. And actually, let's look at where this ant would be. Where would this ant be in 2 seconds? In 2 seconds, without the interference of other ants, this would be at position 2, moving to the right. Okay, so what happens at t equals 2 is we do have one ant at 0 moving to the left, and we have an ant at 2 moving to the right, and we have an ant at 3 moving to the right. The fact that the ants meet and reverse is actually not important. It's actually not relevant. I mean, the ants are in the same place that they would be. They're different ants, but their positions are the same. I guess we could look at it, like just just using these two and do it with 1 second. I mean, so they start off, they run into each other, and they turn around and start going in the other direction. Well, again, without bumping into another ant, after 1 second, we're going to have an ant at 1 moving left. We're going to have an ant at 2 moving right. And in fact, that is what we have. We don't have the blue ant here moving right, and we don't have the black ant here moving left, but we do have an ant. And it doesn't really matter which one. So the key observation is that the ants meeting and reversing is exactly the same as far as the position and motion of ants as if they just went right past each other. So all we have to look at is ants moving left. Which ant is going to fall off last? And that would be the ant at the highest position. For the ants moving right, which ant is going to fall off last? And that would be the ant at the lowest position. Once we have those two, hold on. Last one. Okay, yeah, and then we have the max of each of these. So, yeah, in this case, it's going to be the n minus 0. This, not this ant, but an ant will fall off the plank, moving right at t equals 4. And that, is, in fact, is the case down here. So let's run this. Okay. Again, I haven't heard of this. I have not heard of this question being asked in an interview. You can figure it out based on the picture. You could draw a picture. You'd have to be fairly insightful in your drawing methods. But I mean, now that you've heard it, it's a very easy problem. The media, I mean, based on the algorithm is very easy. The median thing is coming up with it on the fly if you have never heard it before, and if you don't have a nice drawing to work with. So anyway, that's it. Go ahead and like the video, subscribe. I'll send you problems of the day in your inbox every weekday, and we'll see you next time.